Welcome to another video of Optatube. You know, you flip a light switch and you just expect it to work. We all do. But behind that simple flick of a switch, whoa, it is one of the most complex balancing acts on the entire planet. Today we're going to dive into the invisible engine that makes all of modern life possible, the electricity grid, and the really surprising operating system that keeps it all running.
So let's just jump right in with the big question. Why is electricity so incredibly hard to manage? I mean, we trade oil, we trade grain, data, all day long. But electricity, wow, it is just in a league of its own. And the answer to that question is really the key to understanding why our entire power system is built the way it is.
And look, to really get that answer, we first have to wrap our heads around the sheer, almost mind-bending difficulty of the problem itself. Before we can even start to appreciate the solution, we have to grapple with what makes managing electricity such a unique challenge.
Okay, this slide really breaks it down into the 4 core headaches of running a grid. First off, electricity has to be produced at the exact instant it's consumed. You can't just stockpile it in a warehouse. Second, it flows according to the laws of physics, not some business contract. Third, it's traveling through a congested network, basically a system of electrical highways that can and do get jammed. And finally, it requires this constant, split-second balancing act just to keep the lights on.
Let's dig into that first one a bit more. Instantaneous balance. This is the absolute, non-negotiable, golden rule of the grid. The amount of power being generated has to match the amount being consumed. Not just every minute, but every second, every millisecond. If there's too little power, you get blackouts. If there's too much, you can literally fry the equipment. It's a constant, high-wire act with almost no safety net.
And then you've got this little gem from your old physics class, Kirchhoff's laws. See, when a generator pumps out power, you can't just tell it, hey, take this specific wire. Nope, it's going to instantly spread out across every single possible path to get to the customer, always following the path of least resistance. You can't write a contract to force it from point A to point B. You just inject it into the grid and physics takes over.
And if all that wasn't complicated enough, the power plants themselves aren't just simple on-off switches. I mean, we're talking about massive, complex machines. A giant coal or nuclear plant can take hours, sometimes even days to start up. They have strict limits on how fast they can ramp their power up or down. These physical, real-world engineering facts just add another thick layer of complexity that has to be managed every single minute of every day.
So you've got this incredibly complex physical system, right? With instantaneous demands and all these rigid constraints. How on earth do you coordinate all of it? You can't have one person in a control room making every single decision. The answer, it turns out, is both super elegant and incredibly powerful. You build a market that acts as the grid's operating system.
And this, right here, is probably the most important takeaway of this whole thing. This isn't about politics or ideology. It's about pure operational necessity. For a modern, complex grid, markets aren't some optional feature you can add on. They are the very foundation, the operational core that allows the entire system to function reliably and hopefully affordably.
So what does this operating system actually do? Well, it's constantly juggling 3 critical jobs. First is something called unit commitment. Think of it like deciding which taxis need to be out on the road for tomorrow's rush hour. It tells power plants a day ahead of time that they need to warm up and get ready. Second is economic dispatch. This is the real-time part, telling each of those running plants exactly how much power to produce, minute by minute. And third, it calculates the price of that power for thousands of specific points all across the grid.
Okay, so a market runs the grid. That's the big idea. But how? How does it actually work? Well, it all comes down to the absolutely ingenious way it uses prices to solve these huge physical challenges.
The whole thing is built on a concept called the merit order. Basically, the system goes to every power plant and asks a simple question. How much does it cost you to produce just one more unit of energy? Then it lines them all up, from the cheapest to the most expensive. As demand for electricity rises during the day, the system calls on the cheapest plants first. That's going to be your renewables and nuclear. It only brings on the more expensive gas plants when they're absolutely needed. And here's the kicker. The price everyone gets paid is set by the very last, most expensive plant that was needed to meet demand.
But wait, it gets even smarter. The price isn't the same everywhere. Modern markets use something called locational marginal pricing, or LMP, and it's made up of 3 parts. You have the basic energy price, which we just talked about. Then you add a congestion price. Think of this like paying a toll for using a busy power line. If the electrical highway is jammed, it costs more to get the power through. And finally, there's a small loss price, which accounts for the energy that just naturally gets lost as heat when it travels down the wires. Put those three together, and you get the true, real-time price of power at any single spot on the grid.
And that is what makes this whole thing so genius. Check out this example. Location A has a ton of cheap power nearby, so its price is low, maybe 30 euros. But location B is stuck on the other side of a grid traffic jam, that congestion we talked about. To get reliable power over there, the system has to turn on a more expensive local plant. And what's the result? The price at location B is way higher, maybe 95 euros. That price difference sends a crystal clear economic signal to anyone with money to invest, basically screaming, hey, we need a new power plant or bigger power lines right here. It's this level of detail that makes the energy world so fascinating, right? If you are interested in energy market and power system modeling and you want more updates and insights about the global energy market, you should definitely follow the Optatube YouTube channel. We do deep dives like this all the time.
All right, so we've walked through the problem and this really intricate market-based solution. But what's the bottom line? What's the payoff? Why go through all this trouble? Why does this complicated system actually matter to you and me?
Well, the benefits are just huge. All this competition directly helps keep your electricity bill lower than it would be otherwise. It sends those perfect economic signals telling us exactly where to build new stuff. It opens the door for innovators to come in with new technologies for the grid, and this is a big one. It's this exact market flexibility that allows us to integrate massive amounts of renewables like wind and solar. In short, it prices risk in real time, making sure the system is always ready for the unexpected.
So let's bring it all back to our main analogy, because this quote really says it all. The market isn't just a place to buy and sell. It's a huge real-time optimization engine. It really is the operating system that seamlessly blends the hard realities of physics and engineering with the powerful logic of economics to do a job that would otherwise be completely impossible.
And that leaves us with one last really crucial question for the future. This incredible operating system we've been talking about, it was designed for a world of big, predictable power plants. But today, we are fundamentally changing the physics of the grid with renewables. So the great challenge for the next decade is this. How does this amazing system need to change and evolve to handle a completely new energy reality? Because the goal, at the end of the day, is to make sure that every single time you flip that switch, the lights turn on. Thanks for digging into this with us.